do not want to automatically track changes. How did I inadvertently turn this on? Hush!
Hello?
Hello! Can you hear me?
Yes, I can hear you. I apologize for not being able to meet with you at the time that you told me.
Right now my camera's kind of not available because of the YouTube live stream. Sorry about that. So you'll have to deal with me without a camera too.
No worries. If you'd like, we can turn it on if that would make you more comfortable. If not, this is okay as well.
For this first meeting, it's okay. We're just setting schedule for meetings and so forth so that I have your schedule, especially, and so that you have mine, because there are days that I'm going to be out of town that you need to know about, so that we can make sure everybody's okay. Of course, what you have to do initially to get started in class anyway is mostly done virtually, so you're going to be fine. But I also need to give you that assignment and walk you through how to do that, which would be easier if I can share my screen, which I may be able to do. Hey! I can at least share my screen. So, with the massive amount of stuff that's running in the background right now. I also have, for some reason, my Word has decided it wants to start doing stuff I don't want it to do, which is driving me nuts because it's tracking changes that I don't need it to be tracking. And I haven't shared this document, so it shouldn't be tracking those changes, but because I'm sharing my screen, it thinks it ought to be tracking those changes. That's a new one. Okay. Suspect that's one of those co-pilot thingies that I'll have to figure out. That I'll have to figure out how to fix. One of those type deals. So. What?
I was just gonna ask if you would like for me to send you my school schedule on Teams.
Oh, I could go look it up, but I'm used to. I don't need to know that much about your information. What I usually do is I put a shared calendar in a research team. I just haven't set the research team up. And then I make that calendar where you guys can put your schedule on it if you want to share it with me. But the truth is I feel it's important for you to know what I'm doing, but I don't need to know what you're doing. I don't need to track my students. Once we set up when we're supposed to meet, I'm cool with that.
Got it. Okay.
I I think some of that reluctance is my mentor and then collaborator used to track what I was doing obsessively, and I actually didn't realize just how weird that was until a psychiatrist pointed out to me that most bosses don't track and most colleagues don't track their colleagues, and I was like, oh yeah, you're right, they don't.
That's kind of weird.
Yeah, because he would yell at me if I like went somewhere on the weekend instead of working and stuff. And when I mentioned that to my psychiatrist, he's like, "Yeah, most bosses don't track their employees that closely." I was like, "Oh, yeah,
Yeah, no, that's your time off.
yeah, pretty much." Um, so because of that, I am like the direct opposite. I don't want to know what you're doing. As long as you're doing
Okay.
what you're supposed to be doing for me, I don't care when you get it done, and I don't want to know what you're doing in your off time unless you want to share it with me.
Right. Oh, okay, cool. Well, that's good to hear.
Okay, so the first thing you're going to need to do, and luckily this is free, is you're going to need to go to the ACS website. I just shared the link with you. And you're going to need to create an account with them. Okay?
Got it.
Now, that account is free. There's a free level to that account, and there's a free membership, and that's all you need. You don't need the paid membership for what we need to do. Okay?
Right.
Useful things about having a free membership to ACS. There are on careers you can most of their jobs are academic jobs, so it's not most of companies have swapped over to LinkedIn, so they don't really advertise on ACS anymore. They used to, but they don't. But it does have an explore career options and some virtual career services and an ability to kind of research careers in chemical sciences. So there is quite a bit of useful stuff there, even if their inherent find a job is not as important. So
Oh.
it is still in other words a useful website in that regard. What we're going to do and they move it all of the time, which is why I'm having to hunt for it. So they move this all of the time. Okay. So the two courses that you need to take are, so I'm going to share this with you, and again they are free, are the Foundations of Chemical Safety and Risk Management.
Okay.
And the Foundations for Storing, Organizing, and Disposing of Chemicals.
Got it. Okay.
Now, these are incredibly comprehensive courses. One's 17 hours, one is 10 hours. Now, you are taking Chem 291, which is supposed to meet 3 hours a week, and for a 14-week semester. So that is 42 hours. And this is half of it.
Okay, got it.
And that's why I'm not really worried about the fact that I'm going to be out of town in February for you, because you're still going to be working on this. So about half of this semester, you're going to be, you should take, 3 hours. It's done in modules. So you should take, 3 hours at a time and work on a module. These courses were developed by the American Chemical Society in conjunction with Dow Chemical. of here's the safety we would like undergraduate students to begin to learn and get familiar with, so that when they transition from undergraduate labs to research labs to they're going to get a job at our company, we have a foundation to build on. Okay?
Okay.
And that's why Dow was willing to spend the time to work with ACS to develop these courses. Now, I had one of my previous students has a PhD in environmental health and safety. And I had her look at these two courses, and she's like, there's a little bit of it's a little bit idiosyncratic, and there's the exams can be a little bit uber detailed, but all in all, they're pretty good courses. And you will get a certificate from these, and like Richard, who has been working on he's going to graduate at the end of this semester, so we're working on resumes and job searching for him. I told him, put on your resume that you have completed these ACS courses, and that I need to tell him to also put he has his certificate of fitness, because these are industry designed safety courses. They're a start. They're showing a company, hey, I take safety training seriously.
Right.
The other thing you need to complete. My internet is being a little bit grumpy today. Because again, now this is a CUNY requirement, and you're going to have another safety course you're going to need to complete from Queens College Safety, but they haven't sent out the schedule for this semester yet. So I can't tell you which that is, when that is. Now I'm going to augment this research ethics course with a discussion with you about ethics, and that discussion will be based around a certain short story, and we'll talk about that kind of in the middle of the semester. Doing your online training at this point is a good start. Okay. So, by the way, do you guys have to take like Title IX training and workplace violence training as students at CUNY, or is it just faculty that have to take that?
I believe it's just faculty. I haven't had to do that.
Okay. I was just curious.
Yep.
So, some of the issues, this research conduct course, the reason why I augment it is this course is kind of designed for all research students, whether you're doing humanities research or sociology research or chemical research. And because of that, certain practices that we do all of the time and without thought in chemical research and engineering design and research are things you just are misconduct if you do it in political science research. And the reason for that is in like political science research, where you're going to work with statistical data and you're going to have to collect those statistical data, or in biology research where you're maybe going to work with a live animal, you're going to have to truly form a hypothesis, a well-designed hypothesis. You're going to have to write that hypothesis out. You're going to have to write your questionnaires and your experiments out, and that's going to have to be approved by a review board. And once that's approved by a review board, you cannot change it mid-experiment. You can't look at like half the data and go, well, shit, this isn't working, and just stop the experiment before time. You have to see if you say, I'm going to collect data for a semester, you can't stop mid-semester because you're getting a null result from the initial data that you collected. You have to finish collecting data for the entire semester. Now, from a chemistry standpoint, that's like, God, that's such a waste of time. Because,
Right. Yeah.
right, but we're not working with human models and we're not working with statistical data. So, from a chemistry perspective, at least until we get to like trying to test a drug model, we have a goal. And most engineers have a goal. I want to build a bridge from point A to point B. Now, I'm going to design that bridge. I'm going to test my design. I'm going to test it for, all of the things I need to test it for. And if it fails, I am not going to continue on that design because I said that was the design I'm going to use. I'm going to junk it and develop a new design because the goal is I need to get from point A to point B. And that design just didn't work, you see. So engineers and chemists have no issue changing ideas mid-project because we're not driven by an idea, by a hypothesis. We're driven by a goal. We want to accomplish X. But we can do that because the goal we're driven by doesn't impact humans. Well, engineering sort of does, but it only impacts humans after it's built, not before it's built. And the whole point behind testing and throwing out ideas that don't work is to protect humans. So you could say technically they're doing the right thing. Now, some people would argue, but each one of those little bitty tests that you do is a hypothesis on its own, and then you test it, it fails, and you discard it. But that's not really how we think about it. It's just not. So I actually like the textbook that I'm using has another way that they talk about. I mean, they talk about this in terms of doing chemistry homework problems in freshman chemistry. But the truth is it actually is a more nuanced version of the scientific method that works better for physical sciences that are not hypothesis driven. And that method's called COAST. So you observe, you generate ideas or predictions, you test them, you analyze the results, and at every time, you observe, then you use those observations to generate a prediction. You test the prediction, you analyze the results, and then you either refine the experiment, you modify the idea, or you reject it and you start over again. Now, that's a more nuanced version of scientific method than you're normally taught, but COAST is even better. You collect and organize your data. So you collect and organize previous research to help you kind of develop your ideas. You analyze, then you might do experiments. You might do some preliminary experiments and think about it and see, is this going to work or not? So that's kind of the analyze. Then you solve. That would be, okay, my analysis says this might work, so let's do it. That would be the solve stage. And then you think about it. That would be the, did I get the results I was expecting to get? Yes, no. And the truth is a lot of times the answer is no, but what I got, but the no is like, oh, that's far more interesting than if it had been a yes. Because that means I don't understand this the way I thought it did, and something happened I wasn't expecting. So now we have something that's really worth studying. See, most chemists don't actually view a null hypothesis as, oh my God, it didn't work. We view it as, well, damn, it didn't work. I wonder why not. That's another difference between chemistry and engineering and the social sciences. Null hypotheses for us. Well, yeah, null hypothesis for us is like a red flag in front of a bull. Well, why the hell didn't it work?
Right. Yeah. I didn't really see it that way until you mentioned it, and I'm like, huh, you're right.
Yeah. So, I'm saying all of this before I send you to research misconduct because, again, this training is a very broad training versus the training that is more specific to chemistry. So a lot that's in there is very good. A lot that's in here is perhaps not as good. It's still good. It's just not as applicable to physical sciences. Boom. City training requirements. Here we go. Now, when you log into this particular required training at City, there are a lot. Huh?
I just have to log into CUNY first.
No, it'll be. Let me make sure this is the right place. Open link in new window. I actually need to sit down and read it. We have to do this course like every 3 years before we are allowed to submit research grants, and I'm probably due to redo it. Lord help me. You do get tired after a while. Please do not pop up the OTBS. Please. Please, please, please. Because I do not have my phone on me. But it does look like it's the right place, so edit, copy, Control V.
Okay.
Yep. So.
I've already created an account at the ACS. So,
That's good.
That way I can get started.
Yep, it's gonna ask you to log in using your Brightspace login, and it is gonna ask you for the authentication, but that is the right size. But you also have to know which courses you need to take. So, you need to take the Responsible Conduct of Research for CUNY Researchers course. Okay? And I think they used to have an undergraduate version and a graduate version. You only need to take the undergrad. I think they merged that into just one course. So, and I just call it for all CUNY researchers. Yep. And undergrad students involved in research are required to complete the Responsible Conduct of Research within 6 weeks of initiating their research.
Okay.
Then you don't need training in the protection of human subjects because we don't do human subject research. You don't have to do conflict of interest training. I do, but you don't. You do not have to do training in good clinical practice because we are not NIH funded. And you do not have to do training in the care and use of animals because we don't do research on animals. So, that means instead you only have one training course to do, which is Responsible Conduct of Research. That takes, God, I think it takes about 4 hours to go through all the modules, but it's been a long time since I've done it. Like I said, I need to redo it. So, but it's a multi-module course. Keep track of how many hours it takes you to complete it, and please let me know. And it is one of those courses where you can't really fast forward through it. So.
Oh, okay. So it's like around full 4 hours or whatever.
Oh, well, you can do like a module and then leave and stuff like that. It's just when you have to take some of these courses like every year, it would be really nice if you could just get to the end quiz and take the quiz. Because it doesn't change from year to year to year. But you don't have that luxury. This course you don't get to just fast forward to the end and take the quiz.
So you have to go through every single video or activity or...
Yeah, pretty much. Even if the quizzes are really common sense.
Okay.
Now, once you finish Orgo 1, and actually Orgo 2, then if you choose to do so, I'll have you study and take the Certificate of Fitness Safety Training. So the City of New York requires that anybody who wants to work unsupervised in a chemistry lab has to be safety certified. And that's called Certificate of Fitness Training. And then you have to go to a place in Brooklyn to the head fire department for the City of New York in Brooklyn, and take a test, and then they give you a little card, and that's good for I think 2 to 3 years. My card is expired, and they supposedly renewed it, but I never got the new card. I need to remind safety about that. But yeah, so I don't require that of my research students unless, like, if a research student for me wants to work during the summer when I'm with my parents and we're just going to meet once a week, but they want to be in the lab, they have to have a certificate of fitness. Because, right, because they're working unsupervised. So they have to have that. But you can't get it until you have a certain number of hours in the lab, and you don't have those number of hours in the lab until after you've completed Orgo 2, usually. Or Orgo 1 in research.
Oh, okay.
Right.
So, yeah, so I guess that's likely my case then. I have to take Orgo 2. By then, I should have sufficient hours.
Yeah. So anyway.
Okay.
That's your first set of responsibilities. It could be worse. I know it's not looking like that, but if we were to ever start doing experiments again at Brookhaven National Labs, you would be given a list of about 16 safety exams that you would have to complete.
That sounds so annoying.
Yeah, and some of them really are. It's like lead safety. It's like, why? It's like, you solder. I'm like, yeah. It's a small wire. And it's like for a minute. I do not need lead safety to solder a single circuit. What the? It's like, okay, lead safety. It's cool. Do I have to take this every year? The worst.
Yeah, I was going to say, I'm like, is it really necessary to take it every year?
For lead safety, no. It was like every 3 years, thank God. But electrical safety, we had to take every 2 years. And the electrical safety course basically qualified you to plug something into the wall.
Okay.
And then 1 year, all of a sudden, we had to take it in person. I'm like, what? So I show up to take this course in person to maintain my Brookhaven ID. And I sat through the full 3 hours and took the exam. And what I thought to myself as I'm sitting through this course is, okay, which a-hole on this research lab shocked themselves while plugging in their printer behind their desk and actually reported it to safety, hence requiring the entire lab to attend in-person electrical safety training. That is basically spending 3 hours to tell us we shouldn't be plugging in stuff that we can't see. I didn't say it out loud, though, but I thought it. A lot of their safety courses, though, were really good, and I really wish I could copy them. I just didn't feel like I ought to have to take them every year. Their safety course on cryogenic gases, I absolutely at some point am going to have to create a course like that for my students if we get to researching again on supercritical fluids. The course on pressurized fluids, same thing. So there were safety courses that were well done, amazing safety courses. I just felt that they were maybe we had to take them too frequently because a lot of the regulations just don't change that frequently. And if you're working with that material all of the time, you're generally going to remember the safety rules even if you choose not to follow them.
Right.
In other words, beating people over the head with safety rules isn't going to make them follow those safety rules.
Yeah, I don't think so either.
And that's part of what you're going to learn and part of what you're going to see when you take the American Chemical Society safety course and then you take the Queen's College safety course. Because one of the real differences between those two courses is the safety culture in industry learned over time that if you truly wanted to keep people safe, they had to buy into the rules you were imposing. And the only way to get them to buy into the rules you were imposing is if they came up with the rules. So that meant that you had to create a culture where the safety officer was you could kind of view him as an embedded reporter. So the people around them felt comfortable talking to them to work out safety rules of what was as safe, to keep the experiments as safe as reasonably possible, but with an understanding that there are certain things you have to do that may not ever be 100% safe. There are times when you're being as safe as you can be, but it's still not 100% safe. Window cleaners go through that all of the time. I mean, they're hooked up, they got their safety roped everywhere, but shit still happens.
That is true.
Okay? So that is still a dangerous job because you're 100 feet up, 200 feet up, 500 feet up in the air cleaning windows. I couldn't do that job. You could tie me to the thing and I couldn't do that job. But, they have safety rules and they're as safe as they can possibly be in an inherently dangerous job. I've worked at facilities where certain things that were being done, there was just no way that you could do them 100% safely. And the safety officer at the time, he was very good. So he would look and go, yeah, you got as many safety procedures as I can think of, but I'm now going to walk away because this is still not safe, but it's got to be done. That facility, the equipment was bolted to the floor, and in order to maintain stability, the way it was bolted to the floor is you would drill a hole in the concrete floor, you would put in bolts, you would pour concrete on the bolts, then you would put the metal post in the floor, put nuts on the bolts, and then pour concrete on that. And that basically rigidly tied that structure to the floor and created an incredibly stable platform. And that works great until you decide you're going to pull that piece of equipment out and put a new piece of equipment in, and now those things are in the way. So now you got to break all that concrete around those bolts in order to get that post out of the floor so that you can put a new post someplace else. And there's not a lot of ways to do that safely. Now, keep in mind, you're having to do this with a whole bunch of other equipment around you that all cost multi-million dollars. So it's not like you're going to do this recklessly because you can't have concrete flying up in the air willy-nilly and damaging all this other equipment. So you're going to have tons of safety stuff in place, but it's still not safe because basically the way you do that is you put a really, really strong hydraulic jack underneath the edge of that post, and you lift that jack up to put strain on that post, and then you whack it with the sledgehammer and send vibrations down it to start cracking the concrete. And when that concrete finally goes, it goes. So it's yeah, it's not safe. It can never be safe. But it was as safe as it could be made. And he was a good safety officer for being able to recognize the difference. And that, in terms of industry, that's a safety officer that does well in an industrial situation, because he can recognize when everybody's trying to be as safe as possible. And because he could recognize that, people came to him with ideas and let him have input to try to make it as safe as possible. The other type of safety officer is, here are the rules and you must follow these rules because these rules will keep you safe. And the truth is no, they won't. Because if you blindly follow those rules, you're going to end up in a situation where those rules make you manifestly unsafe. Everybody goes behind their back to do things the way they think it ought to be done, and you end up with more safety incidences because everybody's ignoring the safety officer than you would have if people were just, if the safety officer was more reasonable.
Right.
So it is one of those, safety officers have a thankless job. But it's a job that can be done if you treat the people you're trying to keep safe as partners rather than as servants. You must, children, you must do what I say because these are the rules. Yeah, that's not going to work with adults. It just doesn't.
I think that's the reason why people do it. Because they're like, okay, well, you're not going to tell me what to do. So spite is a huge motivator.
And I think a lot of that is really true. Because, most of the environments I worked in, it was more male dominant. And there's nothing worse. I have literally been in a place where the coffee tasted so bad that you couldn't drink it. But nobody would admit it because they were all male. No, this is good coffee. I'm like, this coffee tastes like crap. I want to go get my own coffee pot and make my own damn coffee. And then, of course, everybody's starting to come to my office for coffee. I'm like, well, you have the coffee. You had to walk 2 buildings to get to me to get this coffee. And the other coffee pot is like right across from your office. Why don't you just make a decent pot of coffee by your office? That's good coffee. I'm like, can't be that good. You walked 2 buildings in the Louisiana summer to get this coffee. It's hot outside. Well,
people are ridiculous sometimes.
Yeah. Like, I don't get men. That was my conclusion from that. So anyway, you'll really notice the difference. So on the ACS, they're going to really be focused on learning how to assess your experiment, how to assess your safety, how to look around you and get an idea of what the safety requirements should be for a particular lab or for a particular experiment or for a particular situation. And they're going to emphasize how those safeties procedures can be changing all of the time depending upon how the experiment changes. So, what's working, like in my lab, if everybody's working on aqueous chemistry, then the safety procedures are one thing. But if I got somebody in there that's working on a different project that's using flammable solvents, they're on a different safety procedure. But the people that are in there working aqueous chemistry need to be aware that there are flammable solvents now being used in another experiment, because that changes their safety risk as well. So these type of reassessing your environment, being aware of your environment, is what the ACS training is going to focus on. The Queens College training, when you get it and take it, it's going to be rule-based. So it's a much older style of training. It's way out of favor, but that's the way they're choosing to do safety.
Okay.
And we have to kind of navigate the two.
Okay. So just to recap, I just wanted to confirm. So now that I've made my ACS profile, I have to do the lab safety modules, and also the foundations for storing and organizing and disposing chemicals.
Yep.
And this is in addition to the city program, conduct of research by
Yep.
Queens College, right? So
Yep.
these are the 3 things that I have pending.
Yep.
And when would you like for me to submit all of this by?
Well, like I said, the first course is 17 hours. You're supposed to be working 3 hours a week. So that means that's a 5-week course for you. So sometime in March. The Foundations of Chemical Safety is a 10-hour course. So that would put you, right before spring break on it. The Responsible Conduct for Research course, I want to say it's like 6 hours. So personally, I would do it first, because technically you're supposed to do it within the first 6 weeks of starting research. So technically you enrolled in research for this semester. So within 6 weeks, the first 6 weeks of this semester, you should have completed that course. So do the research ethics course first. And then have the initial safety course done, say, by the end of March. And then have the chemical foundations course done by the end of April, which will be basically the end of the semester. In terms of actually coming to work in the lab, we can start meeting next week remotely, and you can begin to learn how to analyze data, which is an important part of lab work. And you can help Richard Wickman analyze the data he's taking, which will speed up some of what he's doing. And that can be remote meetings, so you won't technically be in the lab when you're not safety trained. Life is good. But as basically the end of March, when you finish your initial lab safety training, you can come to lab.
And it's okay for me to, because unfortunately my lecture does end at 3:30 Mondays and Wednesdays.
Mm-hmm.
So it'd be okay for me, even though I'm not there for the full 3 hours. I can go right after lecture to the lab, right?
Well, right now you can't go to the lab.
Oh, and I meant like after I'm done with all the modules, all the training, and then with your okay.
Well,
after.
You need a 3-hour window. I don't let students come to the lab for an hour. There's just you can't do experiments in an hour.
Oh no, yeah, you're right.
So if this semester you're not really set up to have a 3-hour window, you can do a data analysis, and we can just meet remotely, because data analysis can be done whenever you have time. And then next semester, usually when I take students in 291, it's for their first semester, it's all safety training and ethics training. Okay? And then because they're not really their schedule's not really set up to allow them to really work in the lab. And I know that. So I teach them some data analysis. I teach them some of the background of what we're doing, but it's mostly safety training and ethics training, because you still have to have that done. And then the second semester, they join the lab and start experiments, because then they know, okay, I need to set aside a 3-hour block. And in my case, I know already now for next semester too, that 3-hour block is going to be either Monday from noon to 5. But now, I have computational research projects where you wouldn't ever have to set aside a 3-hour, 4-hour block. But if you want to work in the lab, you have to set aside 3 to 4 hours. It's a requirement. And it cannot be done in less than that.
Got it. So for next semester, I'm just gonna make sure that I have that time free so that I can dedicate it to being present. Because, like you mentioned, there's nothing can be done in an hour. Okay. Yeah, so I will have that in mind so that I can have that time set aside.
Mm.
And you usually work only Mondays and Wednesdays?
And Fridays.
Professor?
I also work all day Fridays.
Okay.
And Friday is research day. Because I don't have any course requirements. It's all research. So.
You usually conduct your work on Mondays and Wednesdays from what time to what time? Would it be like somewhere between 2 to 5?
Noon to 5.
From noon to 5. Got it. Okay. And that's Mondays and Wednesdays.
Yep.
This semester on Wednesdays, I actually have availability till 1 o'clock, but I guess like you mentioned, you have that space from 12 to 5.
I teach a class online from 8 to 10 a.m. at home, and then I have to drive into work. I don't get to campus till noon.
Oh, that's right. Okay.
Right. And then I teach again at 6:30 to 8:30 p.m. at night. So noon to 5 is the time I have to give to research students.
Oh, okay. Oh, right. I took the course with you last semester, so yes. Yeah, the 4 o'clock to 6 o'clock class.
Yeah, well, and now it's 6:30 to 8:30, so. And like I said, I already know what my schedule is next semester, and it's the same as this semester, so it's going to be the same research time.
Okay, so that way I can get my Orgo 2 class. I don't know who's going to be teaching organic chemistry 2 next semester. Hopefully they're I hope that I can definitely. I'm not entirely sure who's teaching it next time. I will take a class that's like on a Tuesday. Anything that's not like the days that you're available.
Well, I mean, you can take a class in the morning or in the evening on those days.
Or for Orgo 2. Yeah, I just want to make sure that I have the time allotted. Like starting now, I just want to make sure that I have that when I sign up for classes, like I'm taking something that's either really, really early in the morning or late in the night or just completely different days altogether.
But and that's why, I'm used to working with class schedules, and that's why I also develop and set aside Fridays. So I show up at 11 a.m. on Friday, and we just work until 8 p.m. on Friday, and that's all research. There's no class that I teach on that day, so that is kind of the research day for all of my students.
Okay.
So that's another option.
Okay. That would be. Also, if Monday and Wednesday is not a possibility, Friday full day is the alternative.
Right. And again, depending on the class you take. So 291 is always 3 hours a week. 391 is 4 hours a week. 391.2 is 6 to 8 hours a week. 391.3 is 9 to 12 hours a week. So it just depends on what class you're taking, how many credits it's worth, and so forth, as to how much time you have to spend doing research.
Right. Wednesdays from 12 to 5. Okay, I was just writing that here. Yeah, so that way I can remember that. And I will definitely get started on these trainings so that I'm on track. I don't want to fall behind or anything like that. And hopefully can finally be in the lab sometime next semester.
Oh, well, if you get all the training done this semester, you'll be in the lab from the very beginning of next semester. And the truth is if you'd pick somebody else, you wouldn't have to do all of this training. But I made the decision that for my students, I would require the safety training before I let them into the lab. Because there's been enough precedents set of principal investigators being held liable and getting thrown in jail because their students got hurt because they weren't safety trained. So, yeah, I choose safety training over lab. And I can do that because the research we're doing right now is all kind of exploratory, and it's all predominantly designed to help train students in techniques for going towards industry instead of getting students papers for going towards PhDs. So because of that, I can hold more of the same type of requirements that you would be held to if you were going in a government job at a government lab or an industrial job. So like at Brookhaven National Lab, you're given like 2 weeks after they hire you to complete your safety training, and you're not actually allowed any place but your office. You're actually not even allowed on site until you complete your fundamental safety training, which is 2 courses. And then once you're on site, you're given the list of other safety training you have to complete, and you're pretty much not allowed to go into your lab or do any work until you've completed all that other safety training. And you're given a certain amount of time to do that. And I suspect that's also true in industry, is once you're hired, you're given a list of safety training modules that you have to complete, and you're not allowed to start your job until you've completed them.
Oh, so that's how that works. Well, I guess you're treating it very much to like real life.
Yeah.
Cool.
And that's because, you know, in my lab, you're not going to get hurt. We're not working with any, well, if you drank it, it would hurt you. And I don't think you're going to drink it. So you're probably not going to get hurt. But, you know, like my mom worked at a pulpwood plant in Louisiana. And there, they classified a splinter as anything under 4 inches in length. Think about that seriously.
Yeah.
I'm like,
I was thinking, letting it sink in.
Mom, she's like, it doesn't require stitches. I'm like, it's what's for. Oh. So,
God, that's massive.
right. So, you know, you didn't get to start on the plant floor, like debarking trees and stuff, until you had been safety trained. Because those debarking machines, if they can pull all the bark off of a tree in under a minute, think of what they can do to a human if you don't follow safety procedures.
Yeah. I don't want to think about that.
Right. So, you know, so they had lockout, tag out procedures and all of that. And she was in human resources and she was responsible for training. So it was her job to meet with new employees and then give them their training modules and make sure they completed their training modules and make sure all their records were up to date. before they were allowed on the floor to start earning money. And then as training, and she was responsible for checking their files and making sure, when a training had expired, that they were pulled back in for training and all of that. So I was like, well, as I re-envision this lab, especially now that ACS has these wonderful free online safety courses, I'm going to treat this just like you would be treated in industry. You don't get to begin my lab until you've done your training.
Yeah, that makes sense. It makes sense. And it keeps everybody safe, even though, like you mentioned, like it's unless you were to drink any of the stuff in the lab. Generally speaking, I guess you're not expecting any of the students to get injured or anything like that.
Not on these experiments. Not on these experiments, but some of the experiments in my lab use lasers. We aren't doing that right now, but we'll be moving towards that in the future. Some of the experiments in my lab use really cold or really high temperature stuff, or high voltage or high current. And when we start playing with that stuff, then even the students that have had this initial safety training, they'll get pulled aside for additional safety training, because that stuff will kill you. And it doesn't take a lot of mistake for it to kill you. So the safety training will be much more extensive, because I'm very aware that this stuff can hurt you bad. And I just don't want that to happen. So we safety train a lot. And you don't get to play with that stuff unless I'm there. And the most dangerous of that stuff, you don't get to do. I do it. Because if somebody's going to get hurt, it's going to be me. But then, since you guys are safety trained, you'll know what to do if I hurt myself.
Right. Okay. So like everybody wins.
Right. I've always viewed it that way, at least.
Yeah.
So.
So, I'm going to get started on these. I believe I'm going to start tomorrow. I just, I'm on top of I have like a pre-lab. I have my lab report due already for the lab. And then we're using Achieve this semester for Dr. Hirsch's class. So that's kind of an experience so far.
You're using what?
This thing called Achieve. Yeah. So you have like online assignments, and a lot of it is, well, like you mentioned, Professor, that you have to draw a lot of things. Well, now I have to learn how to use this thing here to draw all the like all the molecules, and it's kind of a process for me to like actually learn how to use this.
Yeah. Instead
of having a piece of paper and just doing it with my hand,
Right.
I have to use this thing here.
Well, you should still practice drawing by hand, especially like tetrahedrals and hexagonals, because that'll make it so much easier for people to grade your quizzes and your exams, and they will appreciate it so much if you draw this stuff correctly. So it doesn't hurt to learn how to draw it correctly and to practice it, so to look at your textbook and go, okay, draw.
Okay. Yeah, I'm gonna keep on practicing that, and it's just weird doing it on the like this software or whatever.
I mean, there are notebooks, composition notebooks you can get that have the lines in the book that make it easy to draw tetrahedrals. But
yeah, I'm gonna purchase that instead of just plain paper.
But it's still that's one of those things that takes practice. I was never good at tetrahedrals. Still, I'm not good at tetrahedrals. I did practice benzene rings until I could draw them. I can only draw them in one orientation. I can't draw them I can't flip them. I can only draw them up and down. I can't draw them side to side.
Oh, okay. Well, hopefully you can. Well, I'll get through this semester. I'll learn a lot, and maybe I'll get good at it. I don't know. I want
Did
to make sure that I do well.
did the organic reviews that we did in 113, 114, have they helped you or not really?
Yes. No, they have. I was like so thankful that um, you like brought that up in class. Like I thought about you when the class first started, and I'm like, okay, I'm not a stranger to these things. It's not like I forgot this completely. This is still in my memory, so it has helped.
I'd wondered
So I'm
because
really grateful.
Hirsch and I, Dr. Hirsch and I have this conversation about he's not sure that it's helpful for me to teach this stuff in 113. He's of two minds about if that's a waste of my time and a waste of the students' time to teach it that early. And I'm of mind that might as well go ahead and start them now where they've seen it multiple times before they hit Orgo.
Yeah, that's definitely helpful. One of the assignments that he put up on that Achieve thing that we're using.
Uh-huh.
Yeah, yeah, I made flashcards out of because you had us like memorize like the amines and what an ester looks like and stuff like that, and it wasn't hard for me to do that assignment just because I remembered it. I remember what it looked like and everything because of that little review that you held in the class. And I'm like,
Right.
okay, this makes it a lot easier. What would have been like maybe a 40-minute like assignment because I didn't have to go back to my textbook or go on Google and be like, oh, what does an ester look like? What does an alcohol look like? Like I already knew, so I was like, okay, cool.
Oh, that's good. That means I shall keep doing it.
Yes, please do. I mean, I think it definitely helped me out for sure. I don't know about everybody else. I don't know if you remember that student. I think his name is Nicola, something like that. Yeah, he's in my class as well. I don't know if it helped him or not, but it definitely helped me. Yeah, so.
Well, I mean, part of the reason why I'm on live right now is these are on Tuesday, Thursday from 8 to 11, although nobody is attending this one right now. I hold basically body doubling sessions where you can tune in live. I usually have music going. I do my list of homework problems of things I need to get done, and students can do their homework, and they can type their own goals in the Word file and scratch them off. And it just basically gives a 3-hour window where they can do homework.
Okay. No, that's nice. And if they ever have any questions, like they can just ask all the other students that are on there too.
And me. This also doubles my office hours, so.
Right.
So, anywho, that's what's going on right now. So I'm here for till 11 p.m.
Right. Well, this has been really, really cool. I'm gonna just get started on that soon.
If you have any questions about it or anything you want clarified or just something like, is this really true? Let me know. And I'll answer.
I will definitely, yeah.
Oh, let me share one other
Yeah.
thing. Let me attach a file here. Upload from this device. Hopefully it's in an easy to find place. If I'm unlucky, it'll be in a hard to find place. It is not there.
I don't know if you hear all that, but the TV is at full volume in my household, and I'm in my room. I hope that it's not
No, I
too
can't
loud.
hear it. So
You
you're
hear it?
fine.
Okay.
Ah, maybe it's here. Yep. Wait, no. Damn. The questions are here, but the actual thing is not here. Figures. Swear to God, I need to put this someplace where it's easier to find. Okay, well, at least one of these I can send you to download on the web because it's free for students. So let me. Being a scientist. Oh, that may be where it's at. Quit. Ah! Now we're all dizzy. You. Boop. Okay, it's sending. Teaching ethics to students. So, Strand in the Web is a fantasy science fiction short story. I will upload the questions that I ask in that story.
Okay. I just received both of them.
Yeah. So I will upload the questions I usually ask students after that story. At some point, I kind of quit asking the students questions because the PhD students wouldn't read the story. They just felt it was beneath them to be asked to read a story. I did spend some time talking to Christian about the story, and I just asked him. We had a meeting and we just talked about it, and that's what I plan on doing with you. But that particular story, it's interesting for a variety of reasons, and it's fairly deep if you read it in a variety of ways. But what makes that story interesting, at least to me, is it makes a statement at the end of the story about the main character understanding what one of the other principal characters would do, and that's why she'll never ask. And the truth is I don't know what this character would have done, and I could argue both ways. And generally speaking, when I can do that, it means the story is really subtle and is really complex. If I can make a strong argument either direction, So it's usually can be fun if you and reads it carefully. It can be a fun discussion to argue which way they think what this person would have done, and why. A big deal about the difference between doing what's correct and doing what is right. And that's why I usually have students read that story before we discuss research ethics, because there is a difference between those two things. And that story really presents that difference and really sets it up very well. So don't read on being a scientist until you read A Strand in the Web and really think about that subtle difference between what's correct and what's right. I went through a ton of ethics books, hunting a book that was realistic. Most of the time when you read ethics scenarios, you're like, this is so obvious what you ought to do in this case. And it's no real instance in the workplace where you encounter something is it ever black and white. No real instance as a student when you encounter something is it ever black and white. And that's because real people are involved. So, if you see a student cheating in organic, is it correct to go tell the professor you saw so-and-so cheating? Yes. But there's consequences to that. There's personal consequences. If the student finds out that you're a whistleblower, you're going to be ostracized by the students in your class. If the professor finds out a student's cheating and has proof, i.e. visual confirmation because another student saw it, that student's going to get thrown out of the class or get a 0 on an assignment. So there are consequences to it, either direction, and neither set of consequences is great. You see? That's why they actually have whistleblower laws. But even with whistleblower laws, you're still going to be ostracized. And that's something you have to realize, people have said for mechanics that whistleblow at aircraft repair places. That's the right thing to do. Absolutely the right thing to do. Because if a repair is not done correctly, people's lives are in danger. But you're probably going to lose your job for doing it. And you may not ever work in the industry again. So that's a significant issue. And that's why there are whistleblower laws. But those laws, while they're supposed to offer protection, they don't really. I mean, the company cannot fire you directly, but they can make your life so damn miserable you'll quit. You see? It's a big difference.
Okay.
So, the On Being a Scientist book, pretty much every scenario in that book I've seen, or I've heard, or I've either seen it in person, or I've heard about it from another student, or I've watched another student encounter it, or I've heard other professors talk about it. So there is not a single ethics scenario in that book that's not based on a real situation. And that means there's not a single scenario in that book that has a clear-cut solution. And that makes it an incredibly good ethics book.
Mm-hmm. Well, now I'm kind of scared to know what people have done, what they were forced to do in that situation, or thought was the right call.
It's so some of these also come from an ACS ethics book that I loaded for students, but the On Being a Scientist works. Some of these other ones are actually pretty good for ACS ones. And I probably ought to dig up that book and make it available to you guys, the students in my lab. But On Being a Scientist is a good start.
Right. Okay. But I have to read the
Read A Strand in the
other
Web
text.
first. This will be something we can talk about. Now, discussing ethics and stuff, that is something we can do in an hour. So if you want to stop by like on Mondays after February, I'm going to be gone the end of February to the first week in March because my dad is going out of town and he's a little nervous because this last year when he went out of town is when my mom went downhill, and when he got back in town is when they discovered her cancer had metastasized. So even though her scans are before he leaves, in fact her scans are next week, she just had her hip replaced, she's still recovering from that. I will be out of town while he is gone. I will be with her while he is gone, and that just makes sure.
Okay.
That allows him to enjoy his time with his brother fishing without worrying about his wife, my mom. Which is something I can do because I am teaching hybrid. So, say the second week in March, if you want to stop by on Monday when you have time, we can discuss A Strand in the Web.
Okay. So March. So on Monday.
But if you haven't had a chance to finish it because you have other courses, we can shift that. But it's a fun. It's a short story. It's not a full book. It's one of 3 stories in that book. So it's a longish short story. It's a novella. Is technically what it would be called today. And it's worth the read.
Okay. Yeah, I happen to have like a tiny gap from I think it's 12:40 to 1:40. Because I have my lab in the morning
Right.
at 8:30, and then it ends at like around 12:35ish, 12:40ish, and then at 1:40 is my lecture. So I can definitely pop by if hopefully I've read it by then in its entirety, and that way we can like discuss for that time if that's okay with you.
And then at that point, I'll assign you some readings out of On Being a Scientist.
Okay. So that way, yeah. Okay, cool. So that's the track. I'm just writing everything down so I'm able to meet all the goals that need to be met. And every second week, March. February. Okay, there we go. And done.
Okay, well, I'm going to let you go, let you get some sleep and get to work. I'm going to take my dogs out since nobody's on the live stream. So I'm about to take a break. Put the little break clock up and then...
Do your dogs have like outfits to go outside?
No. It's not so cold right now that my cold sensitive one is begging for his coat to go on. Although I did laugh at him the other day because he got up on some snow and he was balanced on it pretty good, and he raised his leg to pee, and that put all his weight on his back leg, so his other leg fell in through the snow. And he's like, he just looked at me like, I want this gone. Because he had, the leg he had raised is now propped up on the snowbank.
Right.
I just looked at him and said, that's an awkward position, buddy. I will give you that. It's an awkward position. But funny. Really funny position.
Yeah, very, very funny. Oh, yeah, it has gotten a lot warmer, so that is, yeah, I really need it.
But it's supposed to be cold tonight. I think we're under I don't know, is it tonight or tomorrow? I'm coming, buds. I saw a sign that said we were going to be scheduled for like major snow.
Okay. Yeah, I haven't heard anything about that. I know that supposedly.
Well, not major snow, just major cold. High winds, wind chills, like negative teens. So I was like, oh, fun.
Oh yeah, that. Yeah. Okay. Wait. So, oh yeah, I think you mentioned that we were just gonna set up like the our like online meets for the following week. Would we be doing that sometime next week then, or?
Um, well, now that you have what you need to do, just touch base with me in chat if you have questions or you want to meet. And we'll do it that way, at least for right now, because this is all done online. So if you're struggling to maintain or
Child and
right
teams here and yeah, okay, sounds good.
Why can't I? Ah, there it is. Yay! Found the timing.
Okay.
Maybe. No. I've not found the timing. Oh well. I'll figure it out later. So.
Alright, Professor. Well, have a good evening. Yeah, and I hope to like read everything that I need to read by March, and that way we can talk about the stories. I'm really looking forward to it. I think it's been a long time since I actually like read even a short story. It's been a long time, so I'm really excited about this.
I've always leaned towards fantasy and science fiction. My mentor always thought it was childish, and thought the stories were too light, but he was also one who would assign like German literature and Russian literature to improve your vocabulary. So, I at least am not assigning you to read James Mond's The Magic Mountain, which, while an interesting book if you like to read, is a horrible book if you don't like to read. I think this short story is not bad.
Yeah, I can definitely do a short story. I feel like if it's a bigger book, it has to be something that really calls my attention.
Yeah.
For me to finish it. Yeah, short stories are great. But yeah, I'm looking forward to that.
Okay. So, talk to you later.
Great.
And
again,
certainly touch base via chat, Teams chat, once a week. And just let me know where you're at, okay?
Right. If it's okay with you, would you be okay with it being like maybe every Monday or maybe, maybe
every Monday's
Wednesday
fine. Just, touch base and say, I've done these modules. I'm about a quarter through, a tenth through, whatever. Just to let me know you're working on it.
Right. Okay. Sounds good. I can give you like a little like start to the week report.
Yeah.
Worked on. Yeah.
That works.
Sounds good then.
That works perfectly.
Great. All right. Have a great evening. I'll talk to you then this coming Monday.
Yep. Talk to you later.
Talk to you later. All right. Good evening.
Okay. Count. Whiteboard. Countdown. I'll figure out how to fix that later.